In lesson 9, we're going to look at using trigonometric ratios to find angles. So we have talked about how to find sides using sine, cosine, and tangent when we know one of the angles. So now we're going to look at how do we find exact angles. So take a look at this picture and see if you can figure out what the measure of the acute angles are, B and C. You can pause the video, try, and then come back. So in this, you could have done a couple different options. So you could have looked at your table and divided different sides. So labeling the sides based on that angle, and then using your right triangle table to try to estimate a value. So labeling the sides from this angle, this would be the opposite side. Okay, this would be the adjacent side, and this would be the hypotenuse. So you could have divided whatever two you wanted and looked in that right triangle table and estimated. That's how we've been doing it. So if you took a look at setting up the trig functions, okay, so if we looked at what the cosine would be of theta, because that's the angle. So the cosine would be the adjacent side 4 over the hypotenuse 5. So you could have looked for that decimal. The sine of the angle, theta, would equal the opposite side 3 over the hypotenuse 5. And the tangent would be the opposite side 3 over the adjacent side 4. So whichever one you looked at, you could have looked in the table for those. Okay, so for that decimal, and then just given an estimated guess. So what we're going to be looking into today is how do we actually do the backwards version of cosine to get the exact angle, since we know we can find exact sides. So the functions that we're actually going to take a look at are called arc cosine. Okay, and that's the backwards of cosine. Whoops, I missed a C there. So arc cosine. And now you say of the ratio, and it will get you back your angle. Okay, or arc sine. Okay, of the ratio will get you the angle. Or arc tan. So then you're able to tell the calculator what the ratio is so it can kick back the angle for you. Okay, and in your calculators, so we're going to take a look and actually solve and get the answer here. So let's just focus on one of these. Let's just look at the tangent. Okay, so here's the triangle again. Okay, so remember that the tangent was opposite and adjacent. So tangent of the angle equals 3 over 4. So then arctan is what we want to be looking at. How do we actually do this in our calculator? So we do the arctan of the ratio to get back the angle. So two different ways that this will appear in your calculator. So in your calculators, it's actually going to look like a tan to the -1. Okay, these are interchangeable. Both of them are the same thing. Okay, arc or tan to the -1. So on your phone calculator, you actually need to type in the division first. Okay, make sure you hit equals. Okay, so you'll do 3 divided by 4, which is 0.75. And once that decimal is on your screen, then you hit second, and then it'll say tan inverse here once you hit tan. Okay, it'll say tan to the -1. So then you hit that once the decimal is on your screen. Okay, so make sure you try this right now. Okay, and that you get an answer of 36.8 or 36.9. So in your calculator, it will say this. So then we'll say that's 37 degrees, but make sure that you know how to do that. And if you don't, be sure to ask what calculator you're using so you can get the correct answer. If it shows on your screen, so if you can see kind of what you've typed in, then you'll hit second tan first. Okay, because then in your screen, what'll pop up, okay, so right here, then it'll say tan -1 with a parenthesis, and then you type in the 3 divided by 4. And then that again will give you this same decimal here. Okay, so make sure that you know how to type it in your calculator before moving on. So then round our angles to the nearest degree. So we got 37 degrees here for theta, which was this angle. And then you can subtract that from 90 to get this angle and get 53 degrees. You could also set up another trig function. So you could do the tangent of angle C. This time the opposite is 4. The adjacent is 3 because we switched to the angle. So then you'll be doing tan inverse or arctan of 4 divided by 3 in your calculator. So that's how we undo it. We're going to keep working with these throughout the lesson. Here's your reference chart to fill in. So one thing to recognize is that this is always going to be between 0 and 1 because it's going to be the adjacent side divided by the hypotenuse. So this hypotenuse is always going to be bigger. So your fraction has to be less than 1. Okay, so it's somewhere between 0 and 1. That's going to be the ratio of the two sides. And then you'll type that in your calculator to figure out the angle. So you've got arc cosine, arc sine will be when you know the opposite and the hypotenuse. And that will always be between 0 and 1 again. And then tangent is the two legs. So these can flip-flop which one's bigger or smaller. So this is just any decimal can go into tangent. Okay, any positive fraction there. So opposite divided by adjacent and do the arctan in your calculator. So let's do one of these together on page 179, and then you can pause the video and try the next two yourself. So I'm just going to use the letters of the angles. You can put a theta in if you would like. Theta is just that Greek letter. I'm just going to use the angle. So I'm going to do angle B. I'm going to find angle B first. So I'm going to label the sides based on angle B. So I'm going to look for this angle. So the 9 is the adjacent side. Okay, next to it, the 10 is the hypotenuse. So adjacent and hypotenuse is our cosine function. Remember, it's on your reference sheet. So cosine of angle B is going to equal 9 over 10. So now to get this angle back, remember we do the arc cosine of the ratio equals that angle. So you need to type that in your calculator. So if you're using your phone, you would do 9 divided by 10. Make sure you hit enter. Okay, so that you have this decimal already before you start trying to do second. So this decimal is 0.9. So then you're going to do second cosine of that. So make sure you see the cosine -1. Okay, so remember that it'll look like this in your calculator. So that's going to be angle B. So angle B to the nearest degree. So it was 25.84 in the calculator. So angle B is going to be 26 degrees. Then you can subtract 26 from 90 to get the other angle, just using triangle sum theorem. Okay, we know all of them total 180. So 180 minus 90 is 90, and then minus 26 gives you 64 for this one. Okay, so you can do 180 minus 90 minus 26 for that, or you can remember these two always total 90. Okay, so that's your two angles. And then you can do a couple different things to get AC. You could set up a trig function now, okay? Or you could do Pythagorean theorem. So Pythagorean theorem would be 10 squared equals 9 squared plus x squared, that missing side. So we'd have 100 equals 81 plus x squared. Subtract 81 from both sides. And then you can square root. So round the side to the nearest tenth. So the calculator gives you 4.35 for that. So you can just do x equals 4.4. So again, multiple ways you could have found the second angle and the other side. Okay, you could set up another trig function to find the angle by using C. Okay, and you could find the side by doing another trig function as well. So why don't you pause the video and try the next two, and then come back and I'll go through them. So have to define which angle you're going to start with. And now this could change, because if you decided to do angle D first versus angle E, that'll change the function. Okay, so I'm going to set up the trig functions for both of these angles. So I'm going to start with D. So then the 4 is the adjacent side, and the 7 is the hypotenuse. So adjacent hypotenuse, again, is a cosine function. So cosine of D equals adjacent over hypotenuse. So then cosine inverse is what you need to type in your calculator to get angle D. So remember, if you're using your phone calculator, that you do 4 divided by 7 first. Okay, and you get 0.57142857, blah, blah, blah. Then hit second cosine, or make sure that the cosine -1 is showing on your screen. And you should get 55.15 for this, so 55 degrees for angle D. So again, make sure you know how to type this in your calculator so that you're not getting it wrong just for not knowing how to type it in. And be sure to reach out if you are struggling with that. So now if I wanted to find angle E using a similar method, okay, now the 4 is the opposite side because it's across from that angle. And then the 7 is still the hypotenuse. So this time I have a sine function. So sine of E equals opposite 4 over hypotenuse 7. So this time I'm going to be doing the sine inverse function of that same decimal. So hit 4 divided by 7, enter, and then do the second, make sure it says sine -1, and you'll get 34.8. So E to the nearest degree is 35 degrees. Okay, so that was equal to angle E, and then we just approximated to the nearest degree. So depending on which function you set up first, okay, you could have solved for the angle, and then you definitely could have subtracted from 180 to find the other one, okay? Then you can do Pythagorean theorem here again. So we've got the hypotenuse, remember that's the C value, equals the 2 legs squared and added together. So that 4 squared and then this missing one. So 49 equals 16 plus x squared. Subtract 16 from both sides, and you'd get 33 equals x squared. Square root that in your calculator, and you get 5.74456. You can round to the nearest tenth. So x equals 5.7. Again, certainly could have set up trig functions now that you know these angles as well. So you could have done like sine, cosine, sine, or tangent, okay, to solve for that x if you wanted. All right, this one, okay, very similar. So again, I'll just set up for either angle. So if I do G first, this is the adjacent side. The 6 is the opposite. And then the hypotenuse is missing. So we would be setting up a tangent function for G equals the opposite 6 over the adjacent 4. So make sure you do the tan inverse of that ratio in your calculator. So 6 divided by 4 is 1.5. And then the tan to the -1 gives you 56.309. So to the nearest degree is 56 degrees. Then you could certainly subtract to get J. You could also set up a function using J as your angle. So this opposite, this would now be the opposite side. This would be the adjacent. So for the tangent of J, the side opposite of angle J is 5. Adjacent to it is, oh, why did I put a 4 in here? Okay, this is wrong. I don't know why I saw 4. All right, we got to go reevaluate that. Now I just wrote 4 again. Okay. All right. Let me get rid of this. Okay, so that should be 6 over 5. So 6 divided by 5 is 1.2. And then the tan inverse of that is 50.19. So 50 degrees. Sorry about that. So then this one with J, the opposite of J is 5. The adjacent is 6. So you would do the tan inverse of that. And you'll get that J equals 40 degrees to the nearest degree. And remember, you certainly could subtract from 180. And then to find the hypotenuse, so we've got x squared equals 5 squared plus 6 squared. So x squared equals 25 plus 36. 25 plus 36 is 61. And then square root that. So x equals, to the nearest tenth, 7.8. So there's multiple different methods you could use that we talked about throughout. Okay, so looking for Pythagorean theorem, doing the multiple trig functions, and then triangle sum theorem. So whichever method you like best, okay, is fine. Use that to solve your problems. Then we're just going to quickly look at applying this to a real world context. So if you're looking at leaning a ladder against a house, there's actually safe ways to do this, that this angle right here is considered a safe angle, okay? That the ladder isn't just going to tip over backwards or fall forwards. So in looking at this angle, kind of a good rule of thumb is that if you stand, okay, here, and you put your hands out parallel to the ground, okay, so this is where the ladder should reach. So your toes should be at the bottom edge. And then when you reach out your hands, they should be on the ladder. So that's a safe, that's a rule of thumb for a safe angle. Okay, so if you don't have measuring tape or you don't have a protractor, you can do that and it'll be pretty safe. That ratio for most people is approximately a 4-to-1 ratio. Okay, so this is approximately 4 feet to 1 feet ratio for the average person. So what are some things that we could think of? So think about some different mathematical things we could think of with this diagram. So you can just pause, look, think about what we could ask as questions about this diagram. Then come back and we'll answer a couple of those questions. So a couple of questions you might have come up with that we could answer is actually figuring out kind of these angles that the body is making with the ladder. So we know this ratio is 4:1. So we could use our new knowledge of inverse trig functions to come up with this angle down here. So if I'm doing this angle, then this 1 is the opposite and the 4 is the adjacent. So that would be a tangent function. Okay, and now I'll just call this theta because there isn't a letter there. So I'm going to say tangent of theta is equal to 1/4. So I can do the tan inverse or the arctan in my calculator to figure out what that angle is. Whoops. So type in 1 divided by 4, hit enter to get that decimal of 0.25, and then do the tan -1. And we get that theta is 14 degrees. Okay, so then when we get that theta is 14 degrees, maybe another question we thought about was that we could figure out this angle here. It's kind of hard to see. This angle here as well. So now we could just subtract 14 from 90 and get that this angle here is approximately 76 degrees. So another question that you might have come up with is, what are the angles in the triangle formed by the ladder and the ground? Okay, or the ladder and these railings up top here. So what are these angles? So what is this one? And maybe what is this one formed at the top here? And I'm just going to call that one alpha, another Greek letter. So think about what those are. How could we figure it out? So one thing that we actually know here is we said we put our arms parallel to the ground. So now that we know this angle here, okay, so we found out that that's about 76 degrees. By alternate interior angles, theta would be the same because this arm is parallel to the ground, and then we've got this transversal. So this one's going to be about 76 degrees as well, which means that this top one is going to be the same as this one that we found at 14. Okay, so they're going to have that kind of those same angles that this person's body has. So you could have written that out. You could say something about alternate interior angles. Okay, and figuring that out. Another thing you might have noticed about making them similar is if this angle is 14 and then here's the ground, the body, the person's body compared to the ground is a 90-degree angle. So if this angle here is 14, then this one would be 90 minus 14, which is 76. So that's another way you could have gotten that 76. And then figured out the 14 from that. So is that the only way to place a ladder? Let's actually look into if we had a 13-foot ladder and we needed to get to the top of a 12-foot roof. So we've got this kind of house here. So I'm just going to draw out the house at 12 feet. So that's a set measurement. Then we've got the ground. Okay, so whatever that ends up being, okay, that'll keep going on forever. So let me draw in kind of this house. Okay, so this is the house. So we're trying to get to the top of this wall. So we're taking a look at this ladder here. We know we have a 13-foot ladder. So we could put it exactly to the top and then bring it to the ground. And is this a safe angle, or is this a safe ratio, is what is wondered here. Okay, so will this be okay? So we just saw in the last example that we want the angle to be less than 76 degrees. Okay, so we found out 76 degrees is an okay angle. Can get a little bit smaller than that, right? So we could get smaller than that. So if this extended out, okay, could be okay for that to get a little bit smaller. So let's take a look at what this angle is to decide if it's safe. So we've got the 12, which is opposite of the angle. And we've got the 13, which is the hypotenuse. So that's one way to figure it out. Okay, opposite and hypotenuse is sine. So we'd be looking at the sine inverse of 12 over 13. Okay, and you can put that into your calculator, and you'll get an angle of 67 degrees. Okay, just over 67 degrees. So is that an okay angle to have? Okay, so if 76 was okay, a little bit less than that is going to be okay, is going to be fine. If it got steeper, then it risks falling backwards. Okay, so 76 seems like it would be okay. Is that the only option? Okay, is it possible for there to be other measurements? So another way you could look at this, okay, is taking a look at if this ladder could move at all. And the ladder can go past the roof, right? It just can't change more than 13 feet. So you could put it closer so that it only hit maybe 10 or 11 feet up the ladder. So we could move it closer, right? So let's figure out how much closer we could move it. So one thing we should probably figure out is where it is when it's farthest away, when this is actually, when the ladder is just hitting the top exactly. So you could do Pythagorean theorem to figure out 13 squared equals x squared plus 12 squared to figure out this base length here. So this is 169 equals, x squared plus 144. So to subtract 144 to both sides and then square root it, and you find out that that's 5. So how far in could we move this? So we know we can't move it out more than 5 because then this ladder wouldn't be tall enough. Okay, so it wouldn't reach up to the top of the building. But how much further in can we move it and still be at a safe angle? So we know that the ratio that's okay is 1 to 4. Okay, let me draw that a little bit better. Okay, so we know that a safe ratio is 1 to 4. So if we have 1 horizontal to every 4 vertical, that's going to be a safe amount. So what do we have here is a vertical of 12. So how big or how far out could this be before it gets to be too steep? So we know this is 12. So we need to find this. And we've got these kind of similar triangles here. So you can set up a proportion. So you can say 1 compared to x equals 4 compared to 12 and cross multiply. So you get 12 equals 4 times x, then divide by 4. So you get x equals 3. You can also notice here that the common factor is 3. So 4 times 3 gives you 12. So 1 times 3 should give you this x. So that means this can't get any closer than 3 feet or the angle will be too steep. Okay, so it can't get any closer than that or the angle will be too steep. So you could move it into 4 feet. Okay, so we could be at 4.5 feet away from the base. We could be at 4 feet. We could be at 3 feet. So 5 feet's the furthest for it to actually just touch the top, or we could be a little bit closer as long as we're not any closer than 3. All right, so here's your lesson summary. So we looked at how to find angles precisely in our calculator. So if we know the 2 sides, we can set up a trig function. So pick the angle, define the sides. So for the one they're talking about, they looked at A. So the opposite of A is 3. The adjacent is 12. That would be a tangent function. So they set up tangent of A equals 3 over 12 and then did arctan or tan -1 in their calculator. Okay, so remember that arctan and tan -1 are the same thing. So in your calculator, it looks like tan inverse. Okay, so arctan is the same thing as tan -1. So if you had the adjacent and hypotenuse, you could do the arc cosine. If you had the opposite and hypotenuse, you could do the arc sine like we saw in the lesson. And then once you know one of the angles, you could do another trig function to find the other one, or you can use triangle sum theorem.